Hi guys. So I wanted to make you a video. I know as you're heading out and talking to people about an HIV cure, an HIV vaccine, there's going to be a lot of skepticism, there's going to be a lot of doubt, there's going to be a lot of questions. And the best thing to combat all these things with are informed facts, and luckily in this case there's a lot of them, and there's a lot of proof behind this work. So I want to break this whole thing down into the man, the science, the plan, and hopefully that will make it very digestible, easy to converse about. And the more you believe in this and the more you're able to talk about it, the stronger it's going to be with so many other people. And that's how this movement is going to happen. It's going to have to be through transmission of knowledge and belief and hope and excitement. So that's what I'm trying to project to you right now. Are you feeling excited? So before I say that, I also want to say this whole movement was formed in the recognition of greatness, of brilliance. When I first saw Dr. Paul's work, every time I speak to him, I get the feeling that this person is really great and is producing great work. And I'm inspired. And if I can help this movement of greatness forward, if I can touch that idea and propel it a small distance, that's an amazing opportunity and one that I want to partake in. And I hope that's why you're participating. That's why we're going to throw this great party. So, the man. This story starts with Linus Pauling. Linus Pauling is remarkable for many reasons, but he is the only person to win 2 Nobel Prizes in different categories, but he's also the most decorated Nobel Prize winner of all times. 2 in science, 1 in peace in his later years with his wife. Most notably, he is known for discovering the covalent bond, the bond that connects 2 atoms together. And besides proven work, he was a huge theorist, much in the same style as Albert Einstein. He theorized on situations and systems outside of his ability to prove them, but still in a very credible and extremely interesting way. One of his most exciting medical theories was that he theorized that the body should be able to produce a second-generation antibody, or an ABZyme, as we'll talk about it today. So that's 1940. We're going to fast forward to 1987. We find our protagonist, Dr. Sudhir Pal, working with an autoimmune disease patient, and he discovers catalytic activity in antibodies this person has naturally produced. This is bringing to life the theories of Dr. Linus Pauling. And Sudhir Pal, 1987, in the height of AIDS and AIDS anger in the United States, dedicates himself in his life's work to using this second-generation antibody technology to combat HIV, but also to take on other intractable diseases. He recognizes this as a powerful tool. That's 1987. So now we fast forward one final time. It's 2009. Over 20 years later, with over $30 million from the National Institute of Health, the most prestigious health organization in the United States, Dr. Paul has a candidate for HIV vaccination ready for human trials. Amazing, as is. So I'm going to try and talk you through the science a little bit so it becomes conversation piece, so it becomes intuitive and integrated within your own understanding. So to do this, we're going to look at the HIV life cycle briefly and current therapies, and then we're going to talk about how ABZymes have the potential to be wildly different. So HIV is a virus, and it has a relatively basic, simple structure. There's a protein shell, there's a bonding site. Within the virus is HIV DNA and transcriptors. So HIV targets the CD4 helper cell in the body. It's one of your most important immune cells. And normally, HIV will target the cell, bond to it, and send its own DNA and transcriptors into the cell, but more importantly, into the nucleus of the cell. HIV will write its own DNA into the nuclear DNA of the cell, turning the cell into an HIV factory. This immune cell is now producing scores of HIV. It will rapidly exhaust itself and die, but not before producing scores of new HIV into the human bloodstream, finding new host sites, eventually leading to the collapse of the immune system, which is known as AIDS. AIDS is the body open to all opportunistic diseases and eventually death. That was before we have antiretroviral therapy. So to break antiretroviral therapy down, you're talking about a therapy that is aiming to block all potential reproduction elements within the HIV life cycle. So what I have here in front of me is lots of antiretroviral medicine in the bloodstream, trying to bond to the bonding site of HIV to prevent it from connecting with the healthy host cell. If it can block all the sites, it will drive HIV viral numbers down and make a healthier body and immune system. So it's an amazing therapy and it has had great success, but there are a lot of negatives to it. It's highly toxic to the body. It requires constant ingestion of medication. It's really expensive. It can be up to $80,000 a year. And it also isn't readily available in the third world due mostly to price. Also, lastly, it's not curative. It's not a vaccine. So it doesn't really fit the bill in the full way that we need it to. Now we're going to look at Abzyme technology as developed by Dr. Paul. So as we mentioned earlier, Abzymes are naturally produced in the human body. Using genetic engineering, the most advanced medical science we have, Dr. Paul has targeted HIV for the Abzyme target. So this Abzyme is sent out to seek HIV, but not the entire virus. It's a small region called the GP120 site. Now GP120 is recognized as an identifiable, consistent region on the HIV outer protein shell in many different scientific studies and communities. So this Abzyme is going to target this region of the protein shell and degrade this singular site. Degrading this site exposes the interior contents of HIV to human plasma. The cell, while broken, HIV can't survive and the cell dies. The Abzyme, however, is preserved and goes after a new HIV unit. So far, what Dr. Paul has been able to prove in the laboratory is that he's been able to immunize mice. He's been able to vaccinate mice to induce the production of Abzymes in them to prevent infection in these mice. Also, he's been able to take these produced Abzymes out of the mice and inject them into vials of infected HIV-positive human blood. In lab studies, a single Abzyme unit has the capacity to destroy 3,000 units of HIV in human blood. This is the vaccination that's ready for trial. So that's the science. Now we have the plan. So what we're doing is we're raising money for Covalent Immunology Foundation. It's a registered 501c3 charity foundation. This will allow Dr. Paul to bring Abzyme technology to the farthest extent it can go in as short a time as possible. By funding this foundation with money, we're going to push this specific science forward as fast as it can go safely and within the limits of FDA certification. So really, we're looking to bring this thing forward. Our event on the 24th of September is going to be amazing. Those $100 tickets are tax deductible, and we're going to have amazing music, people, personalities. It's going to be a great fucking party. So I hope you're excited about it. And lastly, I just want to say this is the democratic support of an amazing medical ideal. One that's already been tried and true and tested and is ready for the next stage. So what we're trying to do is loosen this whole system up and move this ideal forward. As a public, we have the power to move these ideas forward once they pass a certain amount of skepticism and testing. This idea has received over 30 million, as I said, from NIH, and it's also been published in 150 medical journals. So I hope you're feeling excited and inspired, and this kind of clarity and transparency about the science and the movement and what we're trying to do here is the best cure for skepticism, and also the thing that will induce hope and spread the word as quickly as possible. So I hope this was clear and helpful. I'm also going to do this in a PDF. Please come to me or Marie with any questions. Thanks.